And let's solve now problem 24 in page 92 in Segel's biochemical calculations. It asks to calculate the pH of a 0.2 molar solution of an amine that has a pKa of 9.5. pKa is 9.5. So by now we know how to calculate the pKb. That was needed here because it's an amine, right? So the pKb is going to be pKa plus pKb is called pKw, which is 14. Therefore, we can calculate the pKb, that's the unknown here. So the pKb is going to be equals 14 minus 9.5. That gives us the pKb of 4.5. Now that we have the pKb, let's look at the equation here. We have an amine, a certain amine, R, generic, NH2, plus water. It's going to generate RNH3 plus charge in the nitrogen, plus OH minus. So if you start with 0.2 molar, part of it is going to be X, is going to be dissociate, and it becomes X and the X for the product, right? So we have the Kb, so you can calculate X. Kb equals molecular concentration of the products as X times X divided by 0.2. An approximation would be actually 0.2 minus X, but since it's a weak base, we can always approximate. We have the pKb is 4.5, so therefore we need the Kb. That's 10 to the power of a negative 4.5. You can plug this directly in the calculator and find what's the Kb. That would, and then we get the X2 equals 0.2 times Kb. Let's keep as 10 to the power of negative 4.5. Let's use the calculator here. Ten to minus 4.5 or negative 4.5 is 3.16. Ten to the power of negative 5. So x squared again is going to be 0.2 times 3.16 times 10 to the power of negative 5. Then we can calculate x from here. So all at once, and they calculate x is equals 0.0025 In other words, x equal 2.5 times x 10 to the power of a negative 3. That's x. That's the concentration of hydroxide. 2.5 times 10 to the power of negative 3. So if you have your OH concentration, then we can have the POH minus log of the concentration of OH, which is 2.5 10 to the power of negative 3. You can use this thing as a calculator. You can do directly from here. pOH is going to be, there's minus 3 there, and the minus of the log, so there's going to be 3 minus log of 2.5. 2.5. Plug in this thing in the calculator, then we get 2.6. That's the pOH, but we want the pH. It's going to be 14 minus that, minus 2.6, which finally gives the solution for the problem. That's 11.4.